pick up where I left off. I was just about to talk about the process of going from a model and going out of the slicer and then going into the 3D printer. There are about 700 different settings for your 3D printer that affect everything to do with the print being made. You don't have to engage 700 settings every time. You typically work with maybe a dozen settings, speed, flow rates, and things like that. But it's generally, you generally go with the default settings. But once you get into some more specialized work, there's some tweaking and stuff that happens. Infill settings, we change that a lot. So there are several settings that we adjust, and then we take that file once we've run our slice, and then we export that into our machine. We can do that either with a flash drive, taking it from our computer to our machine. We could have a direct connection, a wire connection, or we can do Wi-Fi, and we can transfer those files to that 3D printer in either one of those ways. And then, as I mentioned, the slicer gives us an indication of how long a print will take. And once we get it loaded on the machine, it takes usually a little bit more time. If it says 38 minutes, I would estimate that it's going to take about 45 minutes to run it. But it spits out parts just like that. It spits out parts just like that. And I set up a machine to run, and it finished running while I was talking. So you can see here, right there on the machine is another one of these lithophanes that just got finished running. It took it about 45 minutes to run. Let me see. Is there anything? And before I turn it over to Bill to share with him, I want to share a few more things with you guys that I've made here. 3D prints. I know for a while I was manufacturing Kwanzaa themed products, right? Some of those are here. Where's my, I got a whole set, and I don't, for some reason, oh, here, right here. These are some of the Nguzo Saba themed products that I manufactured. Earrings and necklaces, with the Nguzo Saba symbols. Manufacturing.
The colors there, those are different color plastics from the printer?
Yes, okay. I have a total of 8 3D printers, Bill. 4 of them are dual extruder, meaning that I can print 2 different colors, meaning that I can do duplicate parts, or I can print a part with multiple colors. Matter of fact, got to share this with you. Here's an example of a part that I manufactured, that I made on one of my dual extruder 3D printers. A frog, red and green, interlaced in there, all coming off of one machine. I'm able to print. Well, I don't have this capability on all of my machines, but I've seen machines that can print up to 8 different colors. Or 8 different materials at one time. So 3D printing is a very viable manufacturing technique these days. There are what's called 3D print farms. I have a small 3D print farm. I have 8 machines. So there are mega size 3D print farms where they're doing large scale manufacturing, because for certain designs, for the right type of designs, it's a very, very viable manufacturing approach as an alternative to the high cost of injection mold tooling and stuff like that. One more thing I'm going to show here, these face masks that I was manufacturing at the start of the pandemic, when all my contracts got canceled and, layoffs were happening all over the place, and, we were trying to figure out what we were going to do next. I started manufacturing these face masks that would take a N95 mask, and you'd be able to get more utility out of it, right? Instead of wearing an N95 mask over your face, you were able to take that mask and cut it into a section, and then use that as an insert to place into this mask design here. And then, you know, folks were able to wear this and get the highest level of filtering that was necessary and be able to get some additional use out of those limited number of N95 masks that were available at the time. So I set up a whole company around that and was manufacturing these, sold several hundred of these. As a matter of fact, manufactured them out there in my garage. So and one final thing I'm going to mention, my daughter, in her desk, she was leaning back in her chair, and it tipped over, right? Which, you know, we knew that would happen. We warned her about it, but you know, kids are kids. They don't listen. So it tipped over and busted the back of the busted the adapter that attaches the rear of the seat to the frame. So I came in, did a little bit of got a set of calipers out, took a few measurements. I'm looking for the busted piece. Next thing you know, I had that part. You know, matter of fact, I got to show that. I'm going to show that in my design software. I'm not still sharing my screen, am I? Let me share my screen.
No, not yet. Oh,
let me share my screen because I got to show you that on. Are you able to see my screen?
Yes.
All right, I want to show that in my design software. Where is that at? Did I pull that up? Oh, there's another one that I did. A TV. You know how you lose the back of your the cover for your remote sometimes? I lost the cover for one of my remotes and just made another one, right? This right here is the adapter that I made for the desk chair, right? Just modeled that baby up. It took me about a half an hour to model it. It took it about 2 hours to print. And, you know, within that amount of time, we were back in business. I didn't have to buy a new chair, you know, or go out of my way, you know, to come up with a solution. You know, it took me a half an hour of modeling, maybe 45 minutes of modeling, 2 hours of print, and you know, that chair was back in motion. So I do that all the time around the house. You know, anytime there's a missing part or something like that, you know, where we would be looking at having to throw things away in the past, heck, I jump on this machine, kick up a model, put it on that printer, and next thing you know, we got replacement parts galore. Let me see, what else can I show here right quick?
the broom clamp.
Yeah, let me show you.
Bistable kind of interference piece.
Yeah, I mean, it's a and the thing is, this is 3 different parts, but I printed it as a single part, and all of there's some very thin gaps between it, and the machine recognizes those, right? So I printed this as a single part, and then when I pulled it off the printer, all I had to do was just kind of like twist the parts, and they kind of snapped apart. I put my pins in that were necessary for the pivoting, and you know, and they do this all the time. There are a lot of the toys that are out there that people print are linked like that, you know, and they're like slinky type things, you know, where they're all integrated together and they move, they're movable, you know. So yeah, those are 3 parts, but it printed up as a single, and then they operate it independently. You know, I had them colored here so you can see the 3 different parts, but it printed as one, but they act, you can see the little thin gaps. Look at this, the thin gaps between them. The printer recognizes that, and it leaves that gap there, right? Can you believe that?
Got it.
Let me see, what else do I have to show right quick? Oh, I want to show this because I had what's called a fresh saver container that's used for keeping your produce fresh, fruits and vegetables fresh. Well, one of these, the insert for it got lost. I'm sure it got thrown away. You know, there's this little insert that keeps the food from laying on the bottom of the container, and that allows airflow around it, which is what contributes to the food being able to stay fresh. So when that part was lost, I was looking at either buying a replacement or coming up with some clever solution. So I came in, modeled this baby, modeled this insert right here, came up. Matter of fact, I should, Sarah, if you're able to bring that in here, if you would, so that I can show that.
In fact, I had made something for almost exactly that purpose.
Yeah. I mean, so, I didn't have to throw away that thing, that container, and I was able to restore the function of it. It took me 20 minutes to make this model. Wasn't that long at all, and I think it took less than a half an hour or so to print. So we were back in business very quickly with this. Let me see. Thank you. Bring the container too, if you would. So let me see. I'm gonna stop my share and turn on my camera so that you can see this. This is the actual part right here, and I asked her to bring the container so that you can see it inside of the container. Printed that baby right up, and that container is back in business. Let me see. Thank you. So here's the container, right? This baby drops right down in there. Boom, like brand new. Like brand new. So there's a lot of utility in being able to, create parts like this on your own at home. You not only save the expense, you save the inconvenience, and then it's something to feel good about, and then if you develop your skills on this, then you can become a manufacturer out here. I mean, like I said, I make things that I sell to industry, that I sell commercially here in my garage. And if I were more of a businessman and less of an engineer, I would be making a heck of a lot more stuff, But my love is design. There's a lot that goes into setting up a business manufacturing, right? And I'm good on the manufacturing side, and I've always needed assistance on the other business side where the other things are concerned. But manufacturing is my thing, and I manufacture all kinds of stuff here in my garage. Bill, I'm going to make you a co-host so that you can share what you wanted to share.
One of them's quite similar to what you were just showing.
All right. You should be able to share now.
Yes.
Right. Excellent.
So that's a fruit plate.
Okay.
And I didn't want my melons sitting in their own juice. So I made essentially a fitting like you just showed to go in a container and keep that elevated out of the fluid.
Okay.
And there are 2 or 3 different designs there also on Thingiverse.
Okay.
And then I had made some other things to work with Lego. And of course, Lego has specific pin configurations and shapes and sizes, so you have to have exactly the right matching faces to connect. And I was basically changing a Lego robot into a scribbler type robot. So that tube you see will hold a pin so that as the robot moves, then it lays down ink or marker. So you can draw things with the robot.
Okay.
Again, that was useful for teaching geometry and parametrics and stuff like that.
Okay.
And this was a similar piece. This one snaps into Lego and it holds a marble so that your robot can change without the hysteresis of a swivel. If you have a swivel, then it pushes back at you a little bit when you turn. If you have a marble, it just goes the way that you want. No hysteresis. That's it.
All right. Well, thanks for sharing that. Well, let me ask you all a question. Based on what you all have seen and what I've shared with you, how old do you think 3D printing technology is, and how much do you think it would cost to purchase a 3D printer like the one that I have here that you could use in your own home? First, how long do you think 3D printing has been around? Bill? Somebody, anybody, make a guess.
I'll answer
I
with
want
my.
to.
Oh, go ahead.
I was gonna. The first time I heard about 3D printing was because they were trying to get rid of lower receivers, that folks were ghost gunners that people were printing for lower receivers. But I can't remember. I can't put a pinpoint on that time. That's why I know I'm getting old. I feel like it was only a few years ago, but a lot of stuff that I recall it was like, oh, that was 10 years ago. I'm
Yeah.
gonna guess 10.
Okay. Who else? One more.
I was gonna say the first time I heard about 3D printing was in 2015.
2015. Let me tell y'all this. My first exposure to 3D printing was all the way back in 1993. No, 1994. 1994.
Wow.
I was working in the Space Experiments Department at NASA Glenn Research Center in Cleveland, Ohio, where I designed several space shuttle flight experiments there, and we did the first experiment on the base that was done using 3D modeling. Matter of fact, it was the first experiment designed in NASA using 3D modeling, first space experiment. And we were also, because we were the first to use 3D modeling, we were the first to introduce 3D printing. We weren't doing 3D printing ourselves, but there were companies. The technology, the patents are almost 40 years old, right? And companies that held the patents were not, they weren't widely available. So it was very high, it was very expensive, but they were able to do something that had not been seen before in the industry. They were able to produce prototype parts in 2 or 3 days, right? As opposed to weeks or months that had typically happened. So some of the parts that we designed for the first shuttle flight experiment that I worked on, we had the prototypes manufactured using 3D printing. So I became aware of 3D printing early, and because I had that early exposure on the base, I came to be regarded as the authority on the base for 3D printing. You would have these high-level execs calling me, asking me questions. I would have to do like meetings where I was, giving these execs info on 3D printing and telling them that, we needed to get up to speed on it and all of that stuff. So my exposure to it goes back over 30 years, or about 30 years. So it's been around for a while. Second, how much do you think it costs? What do you think it costs to get into 3D printing?
First time I actually saw one available to print was literally about a year ago, or purchase, excuse me. It was right in Ontario, and I think that one cost. I don't know how much yours cost. I'm gonna guess yours probably about 2,500. But the ones that I saw was only about 400.
Okay, I want to tell you this. Just like everything, there's a range, right? There are. I mean, especially if you start talking about metal 3D printers, because metal 3D printers are out there too, and when I last checked metal 3D printers, you couldn't get a reasonable metal 3D printer for less than $50,000. That's coming down because technology is advancing and there's competition out there that'll drive that down. Just like 3D printing for plastic was ridiculously expensive at one time, and you can still spend $2,500, $5,000 on a 3D printer, that would do different types of plastics or fiber, nylon fiber, carbon fiber, those types of things. That's still out there, but entry level, starter home-based 3D printers, you can get one of those on sale for as little as, get ready for this, $150. As little as $150 on sale. Ender is the most popular starter 3D printer out there right now. I only recommend Ender 3D printers to people who have some mechanical aptitude and who are going to be able to go in and make some modifications and upgrades and all of that stuff. So, they typically run about $250, but you can catch them on sale for as little as $150. But by the time you get that machine operating at an optimum level, you will have paid, $500-600 for it, which is why I recommend the people who are interested get you a Prusa, Prusa. Prusa is the standard, the quality standard for home-based 3D printers. You end up spending $600 for that, maybe a little bit more. But a Prusa is ready to go out the box, right? You don't have to do upgrades. You don't have to tweak it. It doesn't require the same level of maintenance and stuff that one of the more affordable Chinese-made 3D printers do. And you'll have a much more pleasant experience, and it'll be so much worth those couple $100, to be able to not have to figure out how to make modifications and upgrades and things like that. You'll spend a lot less time. So just in the time savings alone, if your time is worth anything, that couple $100 extra is well worth the investment. So I wanted to pose those questions to you all, and give you all also the opportunity to pose any questions you might have for me, or to maybe get started doing another demo if you all are interested in that. So go for it.
Yes. I have a question. I'm not sure if you spoke about the software already, but I understand the price of the 3D printing, and I think, or the 3D printer itself, and like the prices of different filaments. But how much does the software cost, or does it cost anything? I'm not just talking about. I guess you could answer about the modeling software as well as the software to print.
Yeah, Slicer software is going to be free. There are some Slicer softwares that you can pay for, if you want some advanced features and functions and stuff like that. But the Slicer software that I use came with my 3D printer, and every 3D printer sold includes a version of Slicer software, so you don't have to purchase that. You just have to have access to your models and, your modeling software if you're going to do some custom pieces.
Okay, and then I'd like to recommend to anyone who's looking for like an easy way into the software, because modeling software can get really expensive. Blender is free. Blender, like the things you put, it's the same as like how you would chop up your food at Blender. It's free software, and then if you get real serious, there's other options like 3D Studio Max and
I mean, but the initial focus should be on the free programs that are out there, like Fusion 360. What's that other one that I was using with one client?
Tinkercad.
Tinkercad is another one, but I was trying to think. It's not Shapeways. What is that?
I use OpenSCAD all the time, but it's a geometric thing.
Yeah. Well, like I said, you can do a search for free 3D modeling programs, just like you do a search for free 3D models, and you'll find several options that Onshape is the one that I was just trying to think of. Onshape.com. That's a free online CAD modeler also that's out there. Again, there's a lot of different materials that you can use on it. And I talked about the cost of the machine. We talked about the cost of software, but let's talk about the cost of the material itself that's used, right? You get a 1 kilogram roll of filament. This is PLA, ranging from $15 up to $25. I've learned that there's a difference in quality and manufacturers, so I tend to stick with a couple of brands that work well on my machines, and those run about $25 for a roll. But you get so many prints out of a roll that by the time, like for example, a part like my mask, for example, my mask would use 20-cent worth of material to print, 25-cent worth of material to print, so the value is there in it. And, even if you get up to your more expensive materials, you're still looking at, very low per part costs. And then there's, like I mentioned, a range of materials. There's even, these are rigid plastics that I'm showing. PLA is a rigid plastic, but they're also flexible plastics. This is a rubber type material, you know, that was 3D printed, right? Flexible, you know, making seals and all of that kind of stuff. You know, it's a lot of different things that can be done. Any more questions? Anybody got any more questions for us on this?
Yes, I have one more question.
All right.
What's the life expectancy on the machine?
Heck, I bought my first machine over 7 years ago. Actually, probably more like 8 years ago. 2014. Yeah, I bought my first machine in 2014. And they have wear parts on them. That's why it's good to buy the higher end machine. Spend $600 or $700 on a Prusa machine, and you're going to get the value that, you know, as compared to 300, 250, 300 on an Ender machine, and you'll see the value. You'll see the difference in the life, you know, in the term of use and the wear on the parts, because they're the nozzles. Where the filament comes out, those are wear items. Those have to be replaced periodically. Sometimes the motors go out. Those have to be replaced. It's a simple pull and replace on this stuff. You know, it doesn't take much for someone who has some mechanical aptitude, you know. So by being able to do that type of repair work, Akir, you can extend the life of your machines. These machines that I have right here, this machine is no longer available. This machine hasn't been on the market for probably 4 years, right? But I know enough about them to keep them running. These are a lot of the parts are universal parts for, you know, many different machines. So I don't have to buy something that's exclusive to this machine. If my motor, one of my motors go out, and on one of my machines, one of my motors is acting funny, I think I'm gonna have to replace it. I'll be able to get a replacement motor for $20. It'll take me 10 minutes to pop it on. I'll be back in business. If one of my belts go out, I can purchase belts and replace those. So it's yet to be seen how long these machines are going to last, Akir. I'm running on 8 years on my first machine, and I think I paid full price for that at the time, which at that time was probably about $350 that I paid for it. I've made that back multiple times over with the items that I've been able to sell that I've made off of it, and with the savings from being able to make products here for my home. Any other questions? Again, this is an example of, you know, how we can benefit ourselves and our community by reconnecting ourselves with technology and mastering, you know, technology. The benefit. I mean, I score cool points here at home with my family, with my wife, you know, with my children, for being able to make things. You know, I save money by being able to make things. You know, I how do I want to say it? I create freedom for myself. I'm self-determined in a sense by being able to make things. The more things we can make that we use, the less we have, the less we're tied to the corporate structures, right? And we certainly need to limit our exposure or our how the extent to which we're obligated, you know, to them for the things that we need as much as possible. So getting into 3D printing is just another way to enhance not only looking at the principles, not only our creativity, our Kawumba, but our self-determination, right? And obviously, it's a way for us to practice cooperative economics, you know, in the way that we're able to manufacture things that we need for each other and to make available for sale. Bill, did you have a final question, comment?
Yeah, yes.
Go right ahead.
About group usage. So here, the library was providing 3D printing services for a while, and my library in Sacramento provided them also. Mm-hmm. But it's not clear how we do that on our own, whether our churches or other community organizations might support such a thing. I'm not sure how that would work. I don't see any within my own reach that are capable of that, but it does seem possible, especially around Los Angeles, where you have high numbers and good tech talent.
Yeah, I mean I'm a little bit disheartened actually that more of our people aren't into 3D printing at this point, and I'm kind of trying to do something about that by trying to share the knowledge about it.
I believe there is a library in Los Angeles that because they have it's basically sort of like a carpenter's or manufacturer's library where you can go in, much like a library card. You can utilize the equipment there. Like they have sewing machines. I believe they had a 3D printing machine, and they had it was a bunch of different equipment that you could utilize, or a printmaking machine, like to make T-shirts and stuff like that.
A makerspace.
Yeah.
Yeah.
I can't remember the name of it, but I'll look it up. I know I saw it on Instagram and I was like, that's amazing. But I thought that they had 3D printing. If I'm not mistaken, I could be wrong though. But either way, they're on the right track and extending these the access to these types of devices. And 3D printing definitely should be high up there.
There's a political tinge to that also. So it's surely no shock that in Florida, that kind of thing has been retracted.
Interesting.
I mean, they understand the benefit of our developing a familiarity with this technology and being able to manufacture things that we need, want, and use. So I'm kind of this is my first stepping out here to try to bridge that gap that you just spoke about, because we don't have enough exposure to this in our community, and the costs are so minimal, and it's not very complicated at all, that we should have a 3D printer in our churches. Our big churches certainly should have that type of function. It should be teaching that type of thing. Our community centers should be teaching that. I offered to do some 3D printing training at the Saturday school at the African American Cultural Center out here, and that's something that that should be pursued. I'm willing to help any entity, certainly any Black organization that anybody is familiar with that has an interest in getting involved in 3D printing. I would be more than willing to provide some consultation for that at no cost, to be able to get them up and running. So if anybody is aware of where that might be called for, might be beneficial, please don't hesitate to let me know about that. With that, we've reached the 7 o'clock hour, and our hour-long conversation about the need for us to reconnect with our understanding of ourselves as innovators of science and technology has come to a close here. I want to thank you all for your participation, for being here, for participating in the discussion, asking some good questions. If you have any follow-up at any point after this, don't hesitate to let me know. So with that being said, I'm going to close out the public portion of our presentation and ask all of our guests who were gracious and kind to join us tonight to go ahead and exit the meeting, and then we'll go ahead and wrap up with our closing conversation as the Inland Area Kwanzaa Group. So thanks again for your participation, and for the members, please stay, and for all of our guests, we look forward to you joining us in a future study group session with the Nguzo Saba 365 study group. Thank you so much.